Good morning students. Today we are going to discuss about basic antenna theory and its concepts. What is an antenna? An antenna is an electrical conductor or a system of conductors. It is used to transmit the electromagnetic energy into space and also receive the electromagnetic energy from space. In two-way communication, the same antenna can be used for transmission and reception. The definition for antenna is, it is a circuit element that provides a transition from a guided wave on a transmission line to a free space wave, and it provides for the collection of electromagnetic energy. In transmit systems, the RF signal is generated, amplified, modulated and applied to the antenna. In receive system, the antenna collects the electromagnetic waves that are cutting through the antenna and induce alternating currents that are used by the receiver. So, in antenna, there is one main phenomenon is used, that is polarization. What is polarization? Polarization is the direction of the electric field and is the same as the physical attitude of the antenna. There are two types of antenna, vertical antenna and horizontal antenna. A vertical antenna will transmit a vertically polarized wave. The receive and transmit antenna needs to possess the same polarization. So, antennas are used to transmit the radio energy into space and also collect the radio electromagnetic energy from the phase. In transmitting antenna, number of systems are used to transmit the electromagnetic energy like amplifier, modulator and other electronic components. So the beam width is the main part in the antenna. So beam width is the angular separation of the half power points of the radiated pattern. So beam width is the another term related to antenna. The definition of beam width is the angular separation of the half wave power points of the radiated pattern. There are many types of antenna. One is half wave dipole antenna. Half wave dipole antenna means it is an antenna having a physical length that is 1/2 wavelength of the applied frequency. It is called Hertz antenna or a half wave dipole antenna. Hertz antennas are not found at frequency below 2 MHz because of the physical size needed of the antenna to represent a half wave. Then another terms and condition related to antenna is radiation resistance. Radiation resistance is the portion of the antenna's impedance that results in power radiated into space. That is the effective resistance that is related to the power radiated by the antenna. Radiation resistance varies with antenna length. Radiation resistance increases as the lambda increases. The another term is effective radiated power, that is called ERP. ERP is the power input value and the gain of the antenna multiplied together. So here dBi means it is a isotropic radiator gain. dBd means dipole antenna gain. Then the radiation pattern. So different wavelengths have different radiation patterns. That means if the antenna length is lambda by 2 means it has a radiation pattern, and if the antenna length is increased to lambda means it has a butterfly type of radiation pattern. So the radiation pattern is an indication of radiator field strength around the antenna. So it is a power radiated from a lambda by 2 dipole occurs at right angles to the antenna with no power emitting from the ends of the antenna. Radiation pattern means the graphical representation of radiation properties of an antenna. It is depicted as two-dimensional cross section. Antenna gain. Antenna gain is an important factor in antennas. So every electronic component has an important part that is gain, the efficiency. Okay, so power output in a particular direction compared to that produced in any direction by a perfect omnidirectional antenna. The antenna gain is the measure in decibel how much more power an antenna will radiate in a certain direction with respect to that which would be radiated by a reference antenna. Thank you.